In this video, we'll be looking at mixed strategy games, which are those without a clear best strategy, which we call a saddle point. Since there is no clear best strategy, each player will choose a mixed strategy, which means they'll choose one option some of the time and the other option the rest of the time. This video is a little different in that we have the whole problem worked out, and we're going to look at it piece by piece. These problems seem long, but once you get the pattern, they're really not too bad. So what we'll do is we'll use two expected values to find a probability. We'll use two more expected values to find another probability. And then we'll multiply those probabilities times the payoff matrix, and we'll get our answer, the value of the game. For this video, we'll use the example of a football game to explain. It's very simplified and unrealistic as far as football is concerned, but it'll work for a basic example. So what we have is two teams, Team A, which is on offense, and can choose either a run play or a pass play. Team B is on defense and can either choose a run defense or a pass defense. So the numbers in our matrix represent the yards gained or lost by Team A. So if Team A runs the ball and Team B chooses a run defense, Team A will lose 6 yards. If Team A chooses to run and Team B chooses a pass defense, Team A will gain 4 yards. If Team A chooses to pass, Team B chooses a run defense, Team A will gain 12 yards. And if Team A chooses to pass and Team B chooses a pass defense, Team A will gain 0 yards. Now, we could check this for a saddle point, and in fact we should if you were working this problem on your own. We'll save some time, and I can just tell you that there is no saddle point, so there's no clear best strategy for both teams. So since there is no best strategy for Team A, its best strategy would be to use a mixed strategy, which means they would run some of the time and pass some of the time. And the same goes for Team B. They'll do best by picking a run defense part of the time and a pass defense part of the time. And so what we're going to find is those percentages. How often should Team A run the ball? How often should Team B choose a run defense? And that's what we'll find. That's going to be our goal for this problem. So the way we'll do that is we'll start off with Team A. Since Team A doesn't know what Team B will choose, what we're going to find is the expected number of yards that Team A will gain if Team B chooses a run defense. And so Team B choosing a run defense. That's this column of our matrix right here. The two options there are Team A will either lose 6 yards or gain 12 yards. And so that's where we get the numbers for our expected value right here. Now, we don't know the probability with which Team A should run or pass. So what we're going to do is we're going to call the probability with which Team A should run the ball P1. And since we know probabilities have to add up to 100%, the probability with which they'll pass we'll call 1 minus P1. So to compute our expected value, we multiply -6 times P1 and then 12 times 1 minus P1. And if you do a little bit of algebra, what you'll get is that that simplifies to -18 P1 plus 12. Now, if you're working along, I'd recommend pausing the video at this point and going ahead and working out that algebra until you get that answer so you can see where we got it. And then unpause the video and we'll move on to the next step. So our next step will be that we want to find the expected number of yards that A will get, assuming Team B chooses a pass defense. So I've got little matrices here so we can remember what the numbers are. Option 2 for Team B was pass defense, so that was either 4 or 0, and so that's where we get the numbers here. Again, we're calling the probability with which Team A should run P1, and the probability with which they should pass 1 minus P1. And so we'll do the exact same thing here. 4 times 1 minus P, 4 times P1 gives us 4P1, and 0 times 1 minus P1 is of course 0, so that algebra is pretty easy. That gives us 4P1. Now, because Team A doesn't know what type of play Team B will choose, the best option is where the expected number of yards, the expected value, is the same regardless of what B chooses. So we're going to take those two expected values and we're going to set them equal to one another. So -18 P1 plus 12 equals 4p1. And we'll do a little bit of algebra to solve for p1, and we get that p1 is equal to 6/11. And so if we look back up here, we called P1 the probability with which Team A should run the ball. So that tells us that Team A should run the ball 6/11 of the time. Now, what that would tell us is if Team A was going to run 11 plays, they would run 6 of them. And so, of course, what that would also tell us is that they should pass 5 of them. And so we'll call that the optimal strategy for Team A. Alright, so now that we know the optimal strategy of Team A, what we want to do is find the optimal strategy for Team B, and that's basically the same process, just looking at the numbers for Team B. Alright, so we want to first find the expected number of yards that Team B will gain, assuming Team A chooses to run. So what you'll notice here is that the expected number of yards for B is based on what A does. And so when it looks like we're finding the expected values for Team A, notice we have -6 and 4. It looks like we're looking at Team A, and in fact we are. Because when we're computing the expected values for Team B, we're basing that on what Team A does. So if Team A chooses to run the ball, our numbers are -6 and 4, and so that's where we get the numbers for our expected value. So since this is a different probability, since this is for Team B, we're going to call the probability with which Team B should choose a run defense P2. And then, of course, the probability with which Team B should choose a pass defense, 1 minus P2. And so we'll do the exact same thing we did earlier for our expected value, -6 times P2, and then 4 times 1 minus P2. And again, simplify with a little bit of algebra. That gives us -10 P2 plus 4. All right, one more expected value. Calculate the expected number of yards that Team B will gain, assuming Team A chooses to pass the ball. So if Team A chooses to pass the ball, that's option 2 for Team A, so that's 12 and 0. So 12 times P2, and then 0 times 1 minus P2. And so that gives us 12 P2. Now you'll notice we're using the same numbers, 12 and 0, even though these numbers are actually reversed for Team B. This is Team A gaining 12 yards, which really means losing 12 yards for Team B. And so we could swap around all the numbers in our matrix, which might get a little bit confusing, but it ends up working out the same either way, so we're just not going to bother with it. So we can just use these numbers the way we got them right there. So we've got the expected value, assuming Team A runs the ball, -10 P2 plus 4, and then the expected number of yards, assuming Team A passes the ball, 12 P2, and we'll set those equal. Again, use a little bit of algebra, and we'll get that P2 equals 2/11. So what that tells us is that Team B should choose a run defense. We know that P2 stands for run defense because that's what we've been referring to it as. 2/11 of the time. And so if Team B were to run 11 plays, they should pick 2 of them to be run defense and 9 of them to be pass defense. All right, so what we've done, we used 2 expected values to find the optimal strategy for Team A, 2 expected values to find the optimal strategy for Team B. So now what we're going to do, we're going to take those and our payoff matrix, and we're going to multiply all those together. So let's look at the numbers that we're going to be multiplying down here. We first found that Team A should run the ball 6/11 of the time. And so, of course, that would also tell us that they should pass the ball 5/11 of the time. We found that Team B should choose a run defense 2/11 of the time, which of course means they should choose a pass defense 9/11 of the time. And so what we're going to do is we're going to multiply the optimal strategy for Team A, which is this matrix right here, times the payoff matrix, times the optimal strategy for Team B. And we multiply those 3 together, what we'll get is the value of the game, 2.18. And when we multiply those together, we're really just computing another expected value. We're multiplying probabilities times the values associated with those probabilities. And so what we get is what we would expect to happen. If we were to do this an infinite number of times, what would we expect to happen? And since all of the numbers are in terms of team A, this tells us that on average we would expect team A to gain 2.18 yards every play.